All right, so for lab today, we're going to be talking and demonstrating kind of some magnetic fields, and you guys should be able to see kind of the effect magnetic fields have on metals today. Um, Today's lab is just basically two parts, really simple. I'll ask some questions throughout it. You guys will answer those questions on your lab papers, the ones that you guys will turn in. Okay, so for today's lab, I've got a couple different things. I have a compass. Some of you guys have probably never seen a compass in your life, but this is what a compass looks like. A compass essentially will point north, or it will tell you which way direction is north. So when I turn the compass, that will tell me, okay, that way is north. All right. The other couple things I have is I have a couple bar magnets here. This is a bar magnet. It's just a magnet that's got north and south on it. Okay, I've got a couple of those. All right, and then I have a plastic container that has some iron filling in it. Right, that's iron filling right there. This is probably going to be a little bit difficult to see in the video today, so I'm going to see kind of how it looks as we're doing it. I may not have you answer any of those questions. Okay. So first thing we're going to do is we're going to kind of see the effect a bar magnet has on a compass. So what I'm going to do is I'm going to place the compass here. I am going to point it north, and then what I'm going to do is I'm going to take this bar magnet, and you should be able to see the compass start to move depending on which pole I have it on. Okay. So when you move the compass, what happens to the needle? That is question number one. So question number one is, when you move the compass, what happens to the needle? I'll move it a couple more times so that way you can see, so you can answer question number one, which is when you move the compass along the bar magnet, what happens to the needle? All right, so that is question one. All right, so I'm going to remove the compass. Okay, we are done with the compass for right now. We'll bring the compass back, I think, next lab. All right, so what we're going to do next is I'm going to take these two bar magnets and I am going to set them up with the two north poles facing each other. Face those right there, and then what I'm going to do is I'm going to take the iron filling, okay, and I'm going to kind of shake it on top of this. And what you should start to see is you should start to see how the iron filling is actually missing in the middle. Okay, it's actually going to miss in the middle. So reason why is because remember, you've got those magnetic fields that are kind of around it, and those magnetic fields are pushing against one another, so it is actually pushing that iron away. Okay, so your second question is, why is the iron filling not in between the two magnets? Okay, that is your second question. So the second question is, why is the iron filling not in between the two magnets? Okay. All right, now what I'm going to do is I am going to take one of the bar magnets, I'm going to spin them, and I'm going to put them side by side, north and south. Okay, and I'm going to take this iron filling again. I'm going to shake it on top. Okay, and what you're going to see is you're going to kind of see the exact opposite of what just happened. All right, you are going to see, let me kind of give that a good shake again. Okay, you're going to see how there is no real gap in between the two magnets. Okay, so question number three is, when you have the north and the south pole pointed towards each other, what happens to the iron filling? Okay, what happens to the iron filling? So once again, question number three is, when you have the north and the south pole towards each other, what happens to the iron filling? Okay, now one thing I want you guys to keep in mind, you see how you have this iron filling all the way out here? Okay, kind of those little lines out there. Those lines actually demonstrate what we one of your vocab words was lines of flux. So if we kind of continue to give this a shake, okay, you'll kind of see how you can start to see some lines start to form out here with those. You can see some lines in here, some lines up there, the iron filling. That is what we call lines of flux. Okay, so this is actually a really good way to see a visual of those lines of flux. So I'll kind of keep giving it a shake. Maybe we can see some good lines of flux here. Okay, you can start to see some more. So you've got some lines of flux there. You can kind of see how this rounds out right there. Okay, that's a real good indicator of the lines of flux in a magnetic field. Okay, when I turn it back to north and north, you can actually kind of still see the same thing. Okay, except the lines of flux look a little bit different. The lines of flux are now pushing away from each other rather than kind of rounding out. You can kind of see how they're pushing out like that. Okay, so that's just a really good sort of visual for lines of flux, because we really can't see magnetic fields to the naked eye in person. We can see them definitely when we work with these iron fillings. So once again, these are the lines of flux right here, the kind of how the iron is pushing out. All right, that's when the like poles are kind of touching each other or facing towards each other. And this is what the lines of flux, like one more time, look like when the magnetic poles are opposite and they are attracted to each other. Okay, you can kind of see how they're rounded at that point. You see how it's super rounded right there. These are rounded right here. You can kind of see them down there where they're rounded as well. Okay, so this is the lab today. This lab was just to kind of show you some of what a magnetic field looks like, what a magnetic field can kind of do in terms of a compass and in terms of iron filling. So go ahead, answer the 3 questions that I asked in the video, and then answer the questions that are posted with this lab assignment. All right, guys, let me know if you have any questions.